This is actually the very end of your study guide, and so we're skipping ahead here to Unit 6. There is not a part of the study guide that talks about Unit 5, so we will go over that in class together. This part talks about Unit 6, so let's read this objective. Analyze the flow of energy, and cycling, will circle that, of matter, such as water, carbon, nitrogen, and oxygen through ecosystems, relating them to the health and stability of an ecosystem. And so this is where we're talking about ecosystems. Remember, an ecosystem looks at the living and the non-living. In fact, we have words for that, biotic and abiotic. And so in Unit 6, we talked about what are the levels of the biosphere, biome, ecosystem, community, population, and niche. And so this is looking at the ecosystem, how living and non-living things interact. Which processes put carbon dioxide into the atmosphere? Putting carbon dioxide into the atmosphere means that you release CO2. So we actually have a diagram here, but it might be really hard for you to see. So you should go back and look in your notes. And there are actually two processes that put carbon dioxide in the atmosphere. Which process, I'll give you a hint, it's just one process that takes carbon dioxide out of the atmosphere. I want to help you with this one. Explain the greenhouse effect in relationship to carbon dioxide in the atmosphere. Remember, carbon dioxide is a greenhouse gas. So it is a greenhouse gas, and it traps heat. So the more carbon dioxide you have, actually the more heat that will get trapped. What effect might increased atmospheric carbon dioxide have on the environment? If you can't answer this, just rewind and listen to me again, because I said something that if we have increased carbon dioxide, what would happen? So rewind if you need to. Next, we look at food web. So this is how matter cycles, and this is how energy transferred. Create an energy pyramid from the food chain: leaves, insects, birds, red fox, and bear. So which one would go on the bottom? Remember, producers always go on the bottom. So our leaves will go here. This is a food chain. It doesn't overlap at all. Now be careful. This doesn't mean that leaves are eating the insects. This arrow represents energy transfer. So where is the most energy in the pyramid? Right down here at the producers or the leaves. Where is the least energy? Well, our top one, this is going to be our primary consumer, our secondary consumer, our third. These are little zeros, mean primary, secondary, tertiary. This is our quaternary or top level consumer. And so the least energy is at the top consumer. So whoever you wrote there. What happens to energy as it moves through a food web? Remember, some of it gets lost. Do you remember what percent of the energy gets lost? Remember, we gain 10%, so you should be able to tell me what percent of the energy gets lost. Assume there are 10,000 kilocalories of energy in the leaves, meaning all the leaves in that environment have 10,000 kilocalories of energy. Estimate the amount of energy at each of the other levels. Well, if we only get 10%, we can actually cover up one of the zeros, and that means we now have 1,000 kilocalories. And then from 1,000, we would go to 100, take off another zero. Here would be 10 kilocalories, and up here would just be 1 kilocalorie. Now, just to explain, a kilocalorie is 1,000 calories. So this means that as we move up the food chain, the amount of energy decreases. What happens as it moves to matter? Oh, let's look at this question. What happens to matter as it moves through the food chain? Matter is moved 100%, meaning that the carbon that's in the leaves will be available to the carbon that's in the consumer. And so this is why we say that matter is cycled and energy is just transferred. Oops, too far. Next, it wants us to explain various ways organisms interact with each other and with their environment, resulting in stability in ecosystems. So it wants you to define the 3 types of symbiosis. Remember, when we define it, sometimes we use plus, minus, and 0 to help us define them. So you should be able to find this in your notes. The predator-prey relationship. In the graph, which organism is the prey and which is the predator? This might be really hard for you to see, but this line that goes like this, these are the hares. And the hares are rabbits, and they are the prey. And this line that I think is dashed on yours, this is the fox. And so we see this interaction between the fox and the hare. Which population increases or falls first? So if you look at this example, we see that the hare increased first, but then the hare fell first. And so the hares are going to increase or fall first because they are the ones being consumed. And the population that increases or falls second is the foxes because they depend on the hare. So if the hare population changes, then the fox population will change as well. 2.1.4, explain why ecosystems can be relatively stable over hundreds or thousands of years, although populations fluctuate. So population, remember, is just one species. So a species might change over time, but the whole ecosystem is pretty stable over time. You should be able to tell me what type of growth curve is shown here. And when we say what is the carrying capacity, we mean what is the number that is the carrying capacity. During what months, this should be what months, were rabbits in exponential growth. Remember, exponential growth is the same as a J curve. So which ones were showing J curve? Then we have another graph, and this looks at human population. Graph 2, U.S. and Mexico. What percentage of the population is between 0 and 4? And so what we need to be able to do here is we need to be able to look 0 through 4 is down here at the bottom. I go to 8 on one side and 8 on the other. That means 8% are males 0 to 4 and 8% are females 0 to 4. So 8 plus 8 is 16. And then for the United States, you would compare this number with this number, and you would add those to get the same thing. Which population is growing faster? Remember, the more young people you have, more young equals growing faster. And so what you want to do now is you want to be able to actually pick out which of these populations. Is Mexico growing faster or U.S. growing faster? And which age group has the smallest number in both of the in both countries? This is actually the end of your study guide. Now it's just time to study the